Okay, the recording has started, so let us start our lecture. Today's topic is the new features of the JavaScript language. As we know, JavaScript is not a static being. It's constantly evolving, developing. JavaScript is a language is based on the ECMAScript specification. ECMAScript are like the rules which explain how the language shall work, explaining all its features. It's like a rule book when you're playing Dungeons and Dragons or Pathfinder. And JavaScript is actually the game you are playing, the programming language, which is updating using these new features. So it's incorporating these new features, which are described in ECMAScript specification, and we can use them to our pleasure and to make our developing experience even more smoother. What's even more amazing about JavaScript is that, as we have learned previously, this language is being run in the browser or in the Node environment. And we don't even have to update to a new version in order to use JavaScript. We can use these features immediately as soon as they release. And this is achieved using what is called transpilers, such as Babel. Transpilers are special software which allow us to downgrade our language. So one moment I will link the Babel website in the chat. So what is Babel? You will learn about it in more detail during the tools lecture, which is a bit ahead. I suppose it's the next one. But for the purposes of this lecture, we shall only know that Babel allows us to write the most new JavaScript just released features, and then, thanks to Babel, our code will be compiled to downgrade it. Like Babel will make polyfills for us. So, for example, we are writing new code using arrow functions, using classes, and then we set up in Babel that, hey, even though I want a smooth developer experience, my project, it shall still support, for example, Internet Explorer, the old one, not the Edge, but the oldest one. And this old browser does not support these new features, but that's okay. Babel will downgrade my code for me. I don't have to worry about it, and I can enjoy all the newest features of JavaScript, simultaneously supporting all the browsers I need. So compilers are amazing and JavaScript is awesome. So for example, with Java, you actually have to like install Java SDK on your machine. You have to update it like from version to version. And that's why even though the newest Java is what, like 14th, 16th right now, lots and lots of projects are still using Java of the 8th version. 8, and they already have 14 released. But JavaScript is not like that. And yes, I'm a JavaScript believer and I don't like Java very much, but that's just my personal bias. Let's move on. So what we will be studying today are lots and lots of new features, new syntax that you have not seen before. And the most important takeaway of today's lecture is that you don't have to immediately begin learning all this new syntax by heart. You should just be aware of it so that when you encounter a working task on your project, you will know that, hey, I can solve this task by using old syntax, but also I remember there was something from the newish JavaScript. I remember reading about that, for example, Nalishka lessons that we will learn today. And so this lecture is meant to expand your arsenal of tools so that you know that, hey, JavaScript knows this and that, and there are lots and lots of new features which are actually meant to simplify my life as a developer. So it is a good idea to brush up on your JavaScript skills each year, because I suppose you have already been told this, that being a developer means studying all your life. It's not that I can say, for example, I have learned JavaScript. this is very much far from true. I'm learning JavaScript every day, and JavaScript is evolving each and every day, or to be more specific, with ECMAScript releases each and every year. New features are constantly being released. New JavaScript frameworks are being released. New libraries appear. New methods of doing things. For example, several years ago, object-oriented programming, OOP, which we have studied previously, has been all the rage, and everyone was writing applications in object-oriented style. Then functional programming became hot topic, and everyone began studying functional programming, FP. And now lots and lots of enterprise applications are written in functional way. And I suppose the next new hot feature is waiting for us just around the corner. So you will be learning each and every day, but for me, that's part of what makes this fun, because your work will never be like doing the same things each and every day and repeating the same operations. You will always feel, at least from my personal perspective, like kind of an adventurer. You see a new task in front of you, and then you think of the best way to solve it. And the more you know about JavaScript, the more you are in the loop of the newest features, the more ways you can imagine to solve this issue correctly and beautifully and write less code. But obviously, we have lots of slides in this lecture. I suppose you can see that we have 60 of them. And please don't worry that you will learn lots of information today. We are just here to make you aware that this new syntax, these new features exist. Some of them, I suppose, you already know, because new JavaScript, it is JavaScript from JS6, and it was released like in 2016, so like long before you began studying JavaScript in earnest. But let's brush up on this, because many technical interviews still asking what is JS6. For example, arrow functions. Arrow functions, I suppose you are already using in your everyday work, in your everyday studies, when you are doing these homeworks. But it's important to note that arrow functions have lots and lots of peculiarities. They're not only about the syntax. These functions, they don't have their own this. They don't have their own context. And that's what makes them kind of like a double-edged sword. So if you are using arrow functions, first of all, you have to write less code, because you can use with arrow function, for example, the most concise syntax is shown on the right of the slide, like const eve. It accepts no arguments, so it will be empty braces, and then you have curly braces. And if you are returning a return statement at the same time, you can even delete the curly braces and even delete your return statement and just write the return value. But the syntax, even though it's very powerful, it's not like the main feature of arrow functions. What is its main feature? Aside from its variations in syntax, as I told you, you can even delete return and curly braces. Like, for example, you can see on the third line, my eve function accepts status, and because it's only one parameter, you can even let go of the braces and just use it as it is. And then if it's just returning some value, or if you can write what is called in programming a one-liner. For example, you're using the array reduce method and you're very concisely doing the task that this function is supposed to do. Then you can also let go of the curly braces and of return keyword, making your code that much easier to read, and again, less code, the better. It's easier to read and easier to debug. But what is very useful is that most of the time when you are working, you will be working with data. Like on our previous lectures, we have studied the AJAX, the asynchronous JavaScript. The majority of time you will be pulling your backend server for some data, receiving it, then parsing it, changing it in some way, and then passing it to your interface, to your components if you are using React or Angular or Vue or any other front-end framework. Most of the time we are working with data. And usually you are transforming data through multiple stages. And these chains of logic, they're usually quite long and utilize complex functionalities. So when you are using arrow functions and you are chaining them, this code looks much cleaner. So for example, here we have an array of objects called heroes. And then with traditional callback functions, for example, we want to filter this array. We want to filter it only for objects which have kind equal to robot. And then we have to map each of the filtered items in this array to return only the hero name. And with arrow functions, we can see that thanks to its syntax, this code looks much more concise and actually easier to write. Like you don't have to think about all of these parentheses that you cannot get rid of with traditional callback functions. So I suppose one of the best things that arrow functions do is reduce noise in your code. Because what we are attempting to do when we are writing any code is to make it easily understandable, not only for us in the moment, but for our colleagues after we have pushed our commit to GitHub or GitLab, and then our colleagues shall review this code and actually use it in the future, build up new functionality based upon it. Or we can also be the ones who will be decoding this code, for example, in several months. I suppose you will encounter such situations when you are looking at some piece of code and you're like, what is this? What sorcery is this? What does this code actually do? Like what? Then you are hitting git blame to see who have actually written this strange thing, and your own name and surname stares back at you, and this commit was done like 6 months ago, and you're like, oh. So yeah, we are writing lots and lots of code every day. And obviously you will not remember what you have been thinking at the exact moment when you were writing your code in some time, like in a month or even in a week, really. So if your code is not easily understandable by itself, if it's not readable, then it is what's called a code of not very good quality. Your code shall be easily readable and understandable without you in person explaining what your code does. And arrow functions, by reducing the amount of noise in our code, by making it more concise, they really help us. What is the peculiar thing about the arrow functions is the this value. So when we were studying together the inheritance in JavaScript and when we were studying the this keyword, we have discussed that arrow functions, they are quite peculiar in that sense that they don't have their own this. So this situation means that when you are writing arrow function and inside of it you have this, it will not be pointing to the function itself. It will be pointing to your parent object. And that can be quite bad if you don't know that it happens. So let me find an example in my code real quick. So yeah, let's imagine we have such a piece of code. Moment, let me link it in the chat for you. I will try to paste it as a code so that it will be nice and pretty. So one moment, and I will select JavaScript here. Yeah, and then I'm sending it. So if you look at this code snippet, we can see that we have an object called shape, and it has a parameter called radius and two methods, diameter and perimeter. Diameter is being defined as a regular function, and perimeter is being defined as an arrow function. What will actually happen when we call these methods is defined by this peculiarity of arrow functions, that they don't have their own this. So when we are looking at the diameter method, the classic one, so in diameter, you can just copy paste this code to your console in the browser and see. In diameter, this equals to shape, to our object. So the code is working as you would expect. But in perimeter method, this actually equals to window, because this arrow function, it does not have its own this. So you have to look like one level above it. This can be very powerful, for example, when you have nested functions and you have to have in this not the parent function, but the object itself. So if you know how to use it, it will be quite powerful. But if it's a surprise for you, then yeah, arrow functions can definitely shoot you in the leg and give you the results you were not expecting. But let's move on from arrow functions to spread and rest syntax. This is also part of ES6, and it's quite common nowadays, but let's brush up our memory. So what is spread syntax? Spread, as it comes from the word spread, for example, spread butter on your sandwich, we are spreading the array that we have. For example, here we have the const robots, which equals to array of strings, Wally and Eve. And we want to add this whole array to another array. We can do this with concat method, but spread syntax again reduces the noise and makes our code more concise, makes it more cleaner. We can just write our new array. Here I write in it, like I have my square braces, captain. This is the first new item in my array. And then I am spreading the old array robots. And instead of like adding captain and then adding inside of it a nested array of robots, I can see that my result will be an array with 3 items. So spread operator spreads my array to its items. And it's very powerful. Also, because it spreads the array to its items, we can easily make copies of an array. If you remember when you were studying the JavaScript basics, JavaScript has 8 data types. 7 of them are primitives, such as string, number, boolean, null, undefined, not a number, big int, and one of them, the object. And we remember that arrays are no more than iterable objects, and functions in JavaScript are objects as well. Objects, they are not being stored by value, they're being stored by reference. This means that when you are creating new array, if you just do it like an old way, one moment, let me open the chat and write a quick example. So for example, I have the const a, which is equal to array of numbers. And if I create a const b, which is equal to a, and then I change something with my a object, for example, if I change my array, if I do something like a push 4 to add a new item at the end of my array, and then I call B, then I will see that B now is equal to what A is equal to. Though I created B before I pushed a new item to A array, it is still changed. Why is that? That's because the arrays and objects and functions are being stored in JavaScript by reference, not by value. So in the memory, even though the JavaScript language does not work with memory itself, we are in the end still working with it. It's just happening under the hood. So let me link a good article on that, stored by reference and stored by value. When you are creating an array, instead of like writing inside the memory just its value, what you are storing inside your variable A in this case, you are storing a link. You are storing a reference to the part of the memory where your actual array resides. But when you create something like a string, then it is being stored by value. So when you reference C, inside the memory, you already have its value, the string. But with our A and B, them being the arrays, we are only storing the reference, the link to actual value. So in essence, both A and B, the same link, the same reference. So when you are changing A, B is also changing because both of these variables are actually pointing to the same reference. So when you actually have like to copy an array to create a separate copy in JavaScript, you can use the spread syntax. So first you are spreading the array to its elements, and then you are writing it, as it's mentioned on this slide, to const copied robots. And if you do it like that, then you have two separate references. Now robots is looking to one reference is stored there, and copied robots has another reference stored inside. And now if you change the robots array, copied robots will not change. So this is quite powerful when you actually need to like hard copy your array. And here's the alternative method when you are not using the spread syntax. Here's the concat method for array. You can concat your robots together. And also you can be spreading even one item. As we can see in the last line, I am spreading the captain, and when you are spreading the string, this will result in your string being separated by each symbol. Okay, let's move on. Spread syntax, it also works for objects. So, for example, here we have kind object. It has a property kind with value human. So we can use spread syntax to break down this object into key value pairs. So here we have let hero, name captain, and then we are spreading this kind object, and we can see that we have just added the key value pair. Instead of a nested object inside our hero, we just have a new property, kind with value human. You will be transforming objects and arrays quite frequently in your day-to-day work, so spread syntax is quite powerful, and it is a very good idea to be more familiar with it. It can be quite strange at first, but it is very powerful. What can we also do? We can do it conditionally. So here's our old example. Kind object with kind equals human, and then we have name object, which has a property name with the value Mary, and then we are creating our hero name captain, then we are spreading kind object, and then we are saying that hey, if we indeed have name object, if it is truthy, then could you please spread the values, the key value pairs from the name object and add it to hero? So we see that everything worked and we have created an object with fields name and kind. But what if we set our name object to undefined? In undefined value equals to what is called falsy in JavaScript. So like null, undefined, not a number, empty strings. These are what are called falsy values in JavaScript. So now name object is falsy. And then we are calling our syntax again. We are checking, is name object truthy? No. Now it's falsy. We have set it to undefined. And so it does nothing. It will not add this new name. Our name will still stay as Captain. It will not change our name to Mary because our name object is undefined. So conditional spread syntax is very, very powerful and you will be using it a lot. But obviously there are some funny cases. So as we know, arrays are also objects. So if we try to spread our robots array inside the hero objects, we can see that it will be a bit strange. Like we have indexes and it's not working as we would like it to. And because string is also actually an object when we are doing boxing and unboxing. Remember when we were talking about inheritance in JavaScript, we studied that even though string, like for example, what we have written in chat, that we have const c equal to string. If I want to call something called c to uppercase, for example, this will work, like I will receive string. But how is it working? It's just a primitive. We have just discussed that string is being stored by value. It's a primitive. It does not have any methods. What's actually happening thanks to prototypal inheritance in JavaScript is that our string primitive value is being wrapped, or in more correct terms, is being boxed inside the string object. And on this string object, we have all these methods to uppercase, to lowercase, and lots of other string methods. We execute this method, we convert this str to uppercase, and then we unbox this primitive value from our string object and return it to the end user. This is all happening behind the scenes under the hood, but that's how these methods are working. I'm just brushing up on this as we have already discussed this in our inheritance lecture. So strange things can also happen for strings because strings are also having this string object wrapper. Array-like objects can also be spread in both ways. So for example, if we have two functions, function volley and if, and function volley will return to us the spread arguments. Arguments, we remember that our functions, they have the pseudo array, as it's called, pseudo array object called arguments. All functions have it, but not arrow functions. They don't have their own context and they don't have this pseudo array arguments. So when you're doing this with array, this could be useful. But when you're doing this with object, you can see that you're receiving like a key equal to index and then the value equal to if. So this can be not very useful unless you wanted specifically this result. So please remember that you shall be very specific what you're spreading. You're working with arrays or you're working with objects. So what is happening? So what is the summary on the spread syntax? from any iterable value. Iterable means that we can iterate through them using like for of cycles. So for example, for each item in array, for key of object, for key in object. So when you are using cycles, when it's possible to cycle through something. So for example, you can even cycle through string for each of its letters. So arrays, strings, maps, sets, array-like objects like arguments in a function. You can spread it to multiple values, and from object, you can spread this to object literals. Rest parameter. This is actually the same syntax. You can see that it's the same 3 dots, but it is doing the opposite thing. So it all depends on how you're using this, in which place of your code you are placing the rest parameter. So rest is the antitome of spread. You are assembling everything together back again. So it's the opposite of the spread syntax. So let's collect all parameters into an array. So here we have robots, and then we are assembling all these parameters into an array. So we are collecting all our robots and returning one of them as an array. So when you are using spread and rest, which looks exactly the same as I told you, it's just the same 3 dots, it can become quite confusing. So you have rest syntax on the left and spread syntax on the right. That's how they are usually used. So if you overuse spread and rest syntax, your code can actually lose readability. So for example, here we have 2 arrays, robots and humans, and this is an example of bad code. Please don't do it like that, because it's very hard to read. So first we, inside the parentheses, we are resting our heroes, combining them, then we are again spreading them, then we are mapping them, then we are again spreading and resting and resting and spreading. So this is not a good idea. So even though spread and rest syntax is quite powerful and very useful, if you are really overdoing it in your code, it can become quite unreadable to other human beings. So please show some moderation when using this. What is also good about REST is that it can be used alongside other parameters. So only one REST parameter can exist, and it must be the last parameter. What we have here is our already familiar to us array heroes with values of 2 strings Wally and Eve. So here we want to add Wally, and then we want to add everything else. So the rest goes to the rest. Then we return the value from our robots. And if we do it like that, then we will receive a syntax error, because rest parameter must be last formal parameter. So if we try to first spread things and then add other things, then we will break our code. So it shall be the last parameter. Okay, let's talk about the next ES6 feature, which is called array and object destructuring. This one you will be using lots and lots of times if you will be writing in the React framework, or as lots of people are calling it, it's not even a framework, it's a library. But nevertheless, onwards. Destructuring assignment. So what it means? It means that we are destructuring from arrays and objects to variables. Lots and lots of time you will have to look inside array or object and get some values from it. Not necessarily everything, just some parts. So you can use this structuring syntax. You can see it on the second line. Like first we have const robots equals to Wally and Eve. And then I'm writing the keyword let. And then I am creating not only several variables. Even previously, before year 6, I could create several variables in one line by separating them with commas. What I'm doing now is that I'm actually wrapping the new names of my values in my square braces. And then I equal all of them to robots. And then we can see that inside of if, we have the first value. So in array, we have all of our items stored in the order we know, like first item of an array has index 0, second item has index 1, and so on and so forth. So the names that I use to assign to my variables actually don't matter. It can be like A, comma, B equals to robots. And we can see that in Wally, we actually have Eve because it was in the second place in my square braces. And in Eve, I actually have Wally stored. So when you are receiving an array, you can easily destruct and get the values you desire from it. What can also happen there when you are combining it with our rest and spread syntax? So here we have const if, which is first combining our robot using rest parameter, and then it's using the spread syntax to then using the structuring assignment. First we spread it, and then we store these values. But if you are doing the destructuring assignment without the keyword, without var, let, or const, you will actually create global variables. Like if you are doing things like that, if you are creating your variables without a keyword before them, without var, let, or const, if you are not using the strict in JavaScript, if you are not using the strict settings inside, then it will just create a var in global scope in shadow mode, which can lead to not foreseen circumstances. So when you are using the structuring assignment, please always use the keyword before, like it will be lets, it will be consts, it will be vars, and nowadays we are mostly using let and const. So don't forget to add the keyword before the structuring assignment unless you want to end up with lots and lots of global variables. So what is happening here on this slide? Here we are destructuring to an array. We have a long array of robots. We are destructuring this. Then we have the individual elements and other robots. We can see that it went to an array. So Wally equals to string, Eve equals to string. And because we are using the rest element, other robots, they are storing not the third element, Optimus Prime, but it is storing all the rest. Like we're using rest as the name says. So it is storing all three of them. And remember that the rest element must be the last. So if we try to, for example, spread other robots in the middle, and after that we have Eve, then we will receive an error. So first all your other parameters, and then at the last place, rest. When you are destructuring objects, we usually have to repeat the object name again and again and again. So for example, here we have object called robots, and most of the time, for example, when you are receiving JSON, you will be receiving it as an object. As we have learned in our Ajax lecture, we receive JSON, it is JavaScript object notation format, and then you are parsing it and you receive the plain JavaScript object. And then, for example, you want to have like data on it. Like on your JSON, there is key value pair called data with some value you want. And you have to just repeat it. Repeat the object name again and again and again, as we have here. If I want to just store the value of valley key, then I'm just writing robots.valley. If I want the if value, robots.if, and I will have to write this like robots valley, robots if, robots, again and again and again. It is very frustrating, like maybe it could be considered understandable, but the structuring is so widely used nowadays that you can save yourself from endless repeating the name of your object and just use the structuring. So here we have like const, and then instead of square braces, I'm using curly braces. So const valley, comma, if equals to robots, and then just with one line I was able to both create the variables I desire and store the values of the keys I wanted. Here, what is important is that the names of the variables shall be exactly the same as the key names. Why? Because we have no other way to access them. In array, the names of the variables when we are destructuring do not matter because we are just getting them in the order, like first goes to this variable, second goes to this variable, and so on and so forth. But in objects, we don't have such a defined order as an array. So in order to correct the structure, we have to call our variables exactly the same as they are called on an object. Otherwise, it will not work. So what are other useful things about destructuring objects? We can also be using default values. So properties can be chosen selectively. For example, here I have an object called robots, and I only desire if and valley, and I don't need currently erdo d2. So I'm only destructuring the ones I need, and then I can destructure erdo d2 later. And if you are trying to do the destructuring and put this equal sign. So when you are trying to like spread something, creating the values at the same time and assigning the value which is not present on your object, then it is not working, it is not a correct syntax. So we cannot be like creating variables using this syntax and then assigning values to them. This assignment is being done kind of behind the scenes. So if you are missing the var, let, or const, if you desire to destructure your object like that, then you can use the parentheses and this code will be working. But again, it's my advice to you to not use the destructuring in such a way, because if you are not using var, let, or const when creating variables, global vars will be created. And this is not what we desire. And also, if we create, for example, we try to destructure some value on robots, key value pair, and here I am destructuring it to Optimus Prime. If we look at the beginning of our slide, we can see that on our robots object, no such property as Optimus Prime exists. We only have Wally, R2D2, and Eve. I will not get an error immediately if I try to destructure it. Instead, the missing value will just be undefined, as we can see at the bottom of this slide. Next, destructuring objects, REST properties. So we actually have the third kind of REST after REST parameters and REST elements. It is called the REST properties, and they also can be quite powerful. So here we have an object. We already remember it, and we have added the microbe key value pair to it. So if you want to add something new, you can use the parentheses like so, and then it will work. So then you are picking up some values using the spread syntax and the structuring, and then in the rest, you will have other robots. So you can destructure it like that. Rest and spread syntax allow us to do lots and lots of things. But what shall we do if we want to save the key value pair under a different name? For example, here I have const robots and I have Wally. And Wally is not a valid identifier because I cannot have like this special symbol inside my variable name. So I can actually do this using this syntax as shown on this slide. I can ask to store the variable under another name. So first I'm signing my new name and then I am storing the old name that I want. And then everything is working as we would expect. Most powerful, of course, is when we combine array and object destructuring. So here we have const robots, and inside of this array, the first item is a string, and the second item is an object. So if I want to destructure this, I can put both the curly braces and the square braces, and everything will destructure correctly, and we can actually unpack property from an object. So here we can see if I console log Wally, I can easily destructure the key value pair from an object which was nested inside an array. So this is quite powerful. If we have a bit more complex objects and arrays, let's see what is happening in this a bit more convoluted example. First, we are creating let if, and then we are creating a function called set robots. And here we are returning a robots array. So we are using the shorthand arrow function syntax. You remember that if we are returning the value immediately, we can drop the curly braces. And here we return an end array, and that's why we have these square braces. So we are destructuring this array. This array will have first item if. Next, we have object destructuring in an array destructuring. So this is not an array with objects. We are just using array destructuring to set our auth robot. And then we see that we have the let robots, which has if and an empty object as a second item. Then we are running the set robots function, and then we can actually see our earth robot, which is equal to default of object deconstruction. And then we have actually a missing array element, which is the object itself that we have been manipulating this time. We have let robots with if, and then we don't have this empty object we had before. So obviously this example is quite convoluted, and usually you will not be doing such things in your code. Like if it's not easily readable, then I suppose it's not the best idea to use it. So spread and rest syntax is amazing, but it shall be used in moderation. Mostly you will be using it to easily get parts of the objects and arrays you desire, or to easily concatenate arrays and objects. But if you are using it not in moderation, things can become something like this, as shown on this slide, and this is usually not the best experience for you and for your colleagues. So, very powerful tool, but shall be used sparingly. Next, ES6 introduced to us shorthand properties and methods, as well as computed property names. So object property shorthand. When with object destructuring, we could end up with lots and lots of variables, and we may easily need to create a new object from them, like to structure them back. So here we have const valley, const eve, and here we are creating the new const robots, which is an object. And here I want to have like a key value pair. I want the key value pair to have the key as the name of the variable and the value as the value of the variable I had before. So we can see that if I'm just writing valley again, Eve, this is not really dry. So we are actually violating the dry principle. Don't repeat yourself principle, one of the most important principles when you're programming. So object property shorthand, this new syntax introduced in year 6 allows us to remove this duplication. So now JavaScript just understands that, hey, I want to create the new robots object, and I want to create key value pairs from these variables. And if I just pass inside these variables, it will automatically create for me the key value pairs using the names of the variables as keys and their values as values, which is quite useful. Next, shorthand methods. This also simplifies our object literals. So when we are defining some methods in object literals, and then we are using a third-party library configuration, and we want to override some of its methods. So we have imported some library, but then we want to partially change what it's doing. Here we have const valley, and then const eve. It's an arrow function which returns us a string. Next, we have long name. It's an object, and we have valley function. So we have a method called valley, and then we have a method called eve. And here we can just return extraterrestrial vegetation evaluator as in the movie. So this will be less explicit, but shorter. So this allows us, instead of just writing valley function, so on and so forth, I can simply just write the name of the method I want, signify with the braces that it is a method, and then just write the contents of my method. So I don't have to like write function and all that. Again, it's just simplifying my syntax. And next, computed property names. Property names are not hardwired values. Let's see the traditional way first. Here we have our valley and eve, and we have an empty object called names. And then with traditional way, we are creating that, hey, can you please create to us new object properties for our empty names object. So first, as you remember, when you are working with objects, there are two ways to create new properties. If I know the name of my property, then I can be using what is called the dot syntax. So for example, names dot name equals Yana, for example. This will add to my names a property called name. But what if I have like let name, which is equal to Yana, as I'm writing in the chat, and then I want to store in my object the value of this variable. Then I'm using not a dot notation, I'm using the square brackets notation. So then it will be like this. I will be using the square brackets to not create a key with the name, but to use the value of the variable. And that's what we are doing here. So with the traditional way, we are creating several properties for our objects. And here we have valley, eve, rd2. But with computed property names, any expression could work. So here we have const long names, which is equal to such an object, and here we have Wally and Eve and R2D2, and we still will create this object successfully, but these names, they can be computed, like we can actually run the if function to receive it. We can even run the reject expressions on my R2D2. So this can be useful, but it can reduce the readability of your code. So it shall be used in moderation, but it still allows us to not repeat like the name of our parent object, in this case the names, time and time and time and time again. So computed property names are quite handy. Okay. As you know, after in 2016 the year 6 happened, the development of JavaScript as a language did not stop. So the language continued to evolve, and previously we have studied in quite a lot of detail the ES6 features, which are nowadays commonly used, but the language is still marching forward. So let's take a look at what has been happening in 17, 18, and so on and so forth. So in 17, this is not the extensive list of new features added. This is just like the main features you shall be aware of. If you are interested in the full list of the features that have been added, you can just look it up, Google it, like ECMAScript 2017, 2018, any year you desire, and you will see the full detailed list. And also there are lots and lots of great articles available, especially on Medium. Okay, returning to our slide, in AS 2017, we received these new awesome features. Padding a string. So there are two new methods, pad start and pad end, that allow you to pad a string with another string to a certain length. This is very useful when you have to submit a string of specific length to the server, and you can just pad it, like add something to the end or to the beginning of the string to make it the length you desire. Previously, you had to add it like manually with spread, rest, temperatures, and all that. Object values. This is a new static method which allows us to return our own enumerable property values of an object as an array. So, for example, if we have an object, let me drop it in the chat. So, we have const names, which is equal to an object, and then we have, for example, and then friend. So if we have such an object, and then on this object we run the object values method, and it's a static method, which means that we cannot run it like on names values. So this will not work if I try to call this method on the names object itself, but I can call it on its like parent object, on the blueprint from which all other objects are created in JavaScript. So this method actually accepts as a parameter the array that I want to be working on, so object values, and then I pass inside the names, and it will return to me an array of the values of the key value pairs. So I will receive an array like this. This is quite useful and is a nice shorthand. Object entries, it works the same, but it will return to me not the values, but the name of the keys. So for example, object entries names will return to me actually the stringified keys. We remember that keys, they are not actually strings, but there they will be stringified, and then I will receive an array which looks like that with strings me and friend. And JavaScript async await, we have touched base upon this when we were studying async JavaScript. So when you are working with promises, async await provide us a new layer of abstraction above the promises. So when you are using async await, when you are creating an async function, it means that whatever your function does, it will actually return a promise instead. So let me just drop a link to MDN. With async, you can actually change any and every string to, or any and every function, sorry, to return the promise. And then you can actually wait for this promise to resolve. Remember that promises are the objects which remember their current situation, like are they pending, are they resolved, and this function will be returning a promise. So let me just drop an image from this article in the chat to make it easier to understand. So if you have a very simple function, for example, function foo, and it is just returning 1. If we add the async keyword before it, it will actually be the same as writing return promise, which resolves to 1. So this is again a shorthand simplifying syntax. And a very easy way to actually make your code asynchronous. And as we have studied in our lecture about front-end optimization, it's usually a good idea to dump more things into your asynchronous loop. So if you want to receive the value of your function, you shall be using the await syntax. So if we just say like const result, just like that, it will equal to promise pending. Because our function is asynchronous and it's returning a promise, we did not wait yet. So it is still a promise, it is not resolved. What we actually shall do, so const correct result will be await the function foo to do its work, because it's asynchronous. We are signifying that, hey, this is asynchronous code. Please wait for this promise to resolve and then give us the answer. So async and await are very nice syntax abstractions above promises and giving us more direct access and easy access to asynchronous code. Next, ES 2018. Object spread operator. Now we can use the spread operator for objects. Then we also received the promise prototype finally method. So this is a static method for promises, and it will allow us to execute the code when the promise is settled, regardless of its outcome. So when we were studying promises, we learned that we can use several special syntax. When the promise is resolved and we want to do something, we are usually using the then syntax. And we can chain it. So then always returns a promise. So we can do then do something, then do something, then do something, and we can chain it indefinitely if we desire to do so. And this is especially useful when you are working with asynchronous data, like when you are receiving your data in JSON. Remember, we were writing such logical chains that first you receive the response, then you are stringifying your response, and then you are storing your stringified response to a variable to actually use it in your code. And finally, it means that some code will run regardless of whether your JavaScript promise has been resolved or rejected. If it's resolved, we are using then. If everything went well, promise resolved, do the then logic. If the promise failed, then part will not run at all. If we want to catch an error when the promise is not resolved, but rejected. Our asynchronous logic was not executed. For example, we did not receive the data from the server with our asynchronous request. We can use catch. And now we have access to finally. This is executing a piece of code after the promise is settled, no matter it was resolved or rejected. So catch will not run if the promise is resolved, then will not run if the promise is rejected, but finally will run in both of outcomes, which is very useful when you are chaining logic. Asynchronous iterators. Now we can iterate asynchronous data sources, which is awesome and amazing, especially when you're working with lots and lots of server requests and receiving quite big data structures. And async generators. Generators in JavaScript is a bit of an advanced topic, so let me just drop an article for you on what a generator is. In essence, it means executing the code not all at once, but generating it like one by one by one. But this is not something that you will be using quite often. So as I told you in the beginning, just remember that such syntax exists. And if you will need to use it, you will know that, hey, actually, we have not only synchronous generators, but asynchronous generators now. But again, this is just for future reference. If you will be using prototype finally and object sprite operators quite frequently, you will not be using generators in your day-to-day work. So this is just like aware that this exists. Okay, moving on. This is quite like the trip down the memory lane. Yes, 2019. Array, prototype, flat. Flatten an array to a specific depth. This is very useful when you have received an array from, for example, again, your server response, and your array is very deeply nested, like it has very, very deep. And using this new method, you can actually flatten this array. Let me again drop the link to a good short article in chat. And here you can see that, for example, we have the array, which is a nested array, like we have array equal to 0, 1, 2, and then inside of it we have like a nested array. So something like that. And with our flat method, we can actually just flatten it. We can remove this nested array and just receive an array of such form. So it will be one-dimensional now. It will not have several nested arrays. And for example, if you have something even more nested, you can actually control the depth of the nesting you want to reach out to. So if you have like a very, very, very nested array, like you have like 1, 0, 1, 2, and then you have an array, inside of it there is an array, and inside of this is an array, and inside of it we finally have 3 and 4. So this is like depth 1, 2, 3. Depth is 3, and if we are flattening only to depth 2, you will output this only as nested array with one nest. And if you actually increase the parameter, so if you say that, hey, I want to flatten this with the depth 3. So if I run the code like this, then I will again output the totally flat array by removing all of this complexity. So this is not like your day-to-day operation, but it can be quite useful to know that it just exists. So just remember that, hey, there is an opportunity to flatten deeply nested arrays in JavaScript now, and you can even control the length. Next, we have the flat map. This allows us to even run a mapping function on every element and flatten the result. So this is like the build-up of the previous function. It means like running map and then chaining flat, but now it is combined in two. Again, even more specific method, just be aware that such awesome things exist somewhere in the universe. Object from entries. So we can convert a list of key value pairs to an object. So we can pass entries there and actually combine them all to an object. Again, quite useful. Optional catch binding. So we can omit the catch binding when the binding would not be used. Again, quite situational, but can be useful. And then we again develop new methods for our strings. Usually when we are working with strings, we are relying on regex regular expressions. So they're called a lot, quite a lot. And one of the most common operations is like remove the first white spaces. Like if, for example, you have a form on your website and your user is inputting his name and a surname. But for example, I was not paying much attention as a user, and instead of inputting Yana, I first hit my spacebar several times and then input my name. And obviously you would want to store in your database not like white space character, Yana. You want to trim my name or my surname or my email or any other user input. You want to trim it so that no leading or ending white spaces remain, so that you only have the string that you want, the data you desire. Previously, it was only possible to do this by regex, and regex are not readable at all. So if you are using regular expression, let me just, regular expression. So regular expressions, they are like language in their own. So regular expressions, they are not easily understandable. Let me just drop for future reference link to a good site, regex1. So if in your career you will have to like change a string, it's mostly done for string. If you need to change a string, for example, I want to change all A's in my string to B's, or I want to very specifically find a string which is matching, like, hey, my string need to have 2 A's and 3 B's and start from Z, or something, then regex are to the rescue. But really don't try to like learn them by heart, to learn how to do the most common operations in your memory. You will always look them up. Like regex, they are not user friendly at all. Like nothing is worse than them. Like just judging from my personal experience and my colleagues' experience. That's why JavaScript is adding more and more methods which are there to actually help us to not use regex, but instead do common operations with a syntax which is easily humanly understandable. Because like when you see regex in code, you have to like actually decode it, spend a lot of time understanding what this code means. It is not easily understandable by humans, but these methods are. Their names speak for themselves. Trim start, you can easily deduce that this means removing the leading white spaces. Trim end, remove the ending white spaces. So quite nice. Next, I would like to talk about in a bit more detail about 2020, 2021, and 22 new features which have been released in JavaScript. They are really awesome, and again, even though they may seem scary at first, they're here to actually help you and make your programming easier. one of the amazing things that was introduced in 2020 to JavaScript is knowledge coalescing. The name itself may be not easily understandable, like this is not trim start, trim end, what like knowledge coalescing mean. So let's dig into it. It's, despite its scary name, very, very useful. So we have already brushed up on during this lecture that in JavaScript we have truthy and falsy values. And we know that in JavaScript, many values are falsy, like empty strings, the number 0, undefined, null, false, not a number, and so on. But lots and lots of times you will actually have to check in your code, not for falsy values, but nullish values. And this means specifically, I want to check if the value is undefined or null. I don't want to trigger this logic if I received a 0, or if I received false, or if I received not a number, or if I received an empty string. No, I want to specifically trigger my logic only if something is nullish, undefined or null. Previously, we did not have like a quick way to check for this. Like if we write like if value do something, this means like if value is true, you do something. If you want to check for falsy, we'll write it like this: if value do something. So if value do something. So we can check for the falsy being false with putting the exclamation mark before it. So previously we had to check for this individual, like if value is equal to undefined, or if value is equal to null, then do something. But now with this nullish coalescing operator, which despite its scary name is just two question marks put together, we can easily check for this. And I have screenshotted some examples of this. So for example, if we have false and some truthy value, then we will log false. But if we have undefined and some truthy value, then we will log some truthy value. And we are, thanks to nullish coalescing, able to very specifically target null and undefined values, which is amazing. Now we don't have to like write, hey, it shall be equal to undefined or null specifically. I don't need all false values. Now we have an opportunity to check only for nullish values, and it's awesome. Next, optional chaining. This is also amazing, especially when you receive a really, really complicated object from your backend server. So you have made some request and you received some data. And you want to look really deep inside, like you have x prop 1 and inside of it prop 2. But what if there was some error on the server and you did not receive this data? So if there is no prop 1 on your object, previously you will just fall with an error, like there is no such value. But now with optional chain, which is again is done with a question mark before the dot, as you can see. So here, if we just chain x prop 1 prop 2, we receive 100 as we would expect. But if we, for example, say x prop 1, then we keep optionally chaining non-existent prop, another non-existent prop, another non-existent prop, and then in the end we want to get some oh yes value. We will not receive an error, we will just receive undefined. This is amazing. This allows us to not fall with an error, but if the value is there, great, we receive it. If there is no such value, then we will not fall with an error. So extremely useful, because previously we had to like explicitly check not to fall with errors like, hey, if x prop 1 exists, like if x prop 1 like is truthy, then we have to go to x prop 1 prop 2, and then if we have to go deeper, then again we have to write the if statement like, hey, if this nested key value pair exists, can we please look deeper inside? Now with optional chaining, we are safeguarded against these errors. If there is a value, we will return it. If there is no value, well, no problem. We will just receive undefined. Big int. This one is a bit more for like the technical interviews, not for day-to-day job, unless you will be working with some big data. So if you are working with big data, if you're working with very, very big numbers, if you don't have enough capability in basic JavaScript, because like for number, the number type in JavaScript, we have like the max safe integer. And this max safe integer is like 9 million billion, if I remember correctly. But nowadays, with big data becoming more and more prominent, you may actually need to store numbers which are much bigger. And this is the new data type in JavaScript. So before there were 7 data types in JavaScript, and now we have one more primitive data type called big int. And for you to use it, you have to add n after your number. So if you encounter such code in your future applications, you will just know that, hey, this is this very specific thing called big int. It's meant for storing extremely big numbers. One good side note is that you cannot do mathematical operations with big int and number without previously explicitly changing the data type. Like you can convert number to big int, and you can convert big int to number if its value is lesser than max safe integer. And after you have converted explicitly them either both to big int or both to number, then you can do mathematical operations. But again, big int is a bit more just to be aware of. If you encounter such a number in your code, you will know that this is this new data type called big int. Dynamic import. This is much more day-to-day, everyday usage compared to big int. Dynamic imports. So now in JavaScript, we can just wait for other modules to load. We can just import JavaScript files dynamically. Previously, it was only being achieved with Webpack and Babel and other tools. And now, coming from 2021, we are able to actually just write this in our plain JavaScript, which is amazing. So we can just await the input of our module and then run some methods which are available on this module. Very, very convenient. Next, promise all settled. 2021 continued to expand the promise functionality. So what this means is that when you have your promises, sometimes you have to wait for all your promises to be resolved or rejected. It means that they, from their pending state, have been changed to their settled state, like they have run. And only after that, you want to do something. Like, for example, you are requesting several backend services and you are receiving parts of data you need from the several backend services. And only after you have received everything you need, then you can move forward with your logic. And now, promise all settled allows you to do this very easily. It will wait for all of your promises to be resolved or rejected, and only after that you will receive an array of values of your promises. So this is a very powerful tool, and I suppose you will be using the promise all settled method quite often. Next, string match all. Again, we are trying to fight back the regex, the regular expressions, and when you have your string and you want to return an iterator that returns all matched groups one after another when you want to compare your strings. So previously you only had to do it with regex, and now you have like the match all method, which allows you to do this iteratively very, very quickly. So you just write the small regex, like only the comparison, not the logic behind it. And then you are just creating an iterator and matching all in your string. This is a more like, just be aware that this exists. This can one day really save you in a pinch, but you will not be using it very often. But it's awesome to know that it's somewhere in the universe. And next, the thing that you will be using quite frequently, global this. So as we have studied when we were talking about inheritance, this keyword can be very tricky. It is not being set when you're writing your code. Its value, it's being identified only when you are running your code. And JavaScript can be run in various environments. For example, if you run your JavaScript in browser, it will be equal to window. If you're running it in node environment, it will be global. And again, a bit of more advanced topic. Also, this is part of asynchronous JavaScript web workers. You can actually run your code not in JavaScript, not in browser, but in web workers. Then this will be equal to self. And if there are any more runtimes, the global object will be different for them as well. So previously, we had to implement our own detection of runtime, like, hey, is this JavaScript being run in the browser? Is this JavaScript code being run in the node environment? And then we had to use the correct global. But we now have global this, which always refers to the global object, no matter where you are. So this is extremely useful when you are writing code which can be run both in browser and both in Node. For example, when you're writing cross-platform, like you have a web application and you also have like an offline application which you can download on your machine, for example, using Electron. And next, but not the least, the very nice shorthand module namespace export. So previously, we had access to import. We are putting a star. It means import everything. Import everything as utils from this folder, and then we are exporting these utils. These were 2 lines. Now we can just skip import as. We can just export everything as utils from this folder. Just a very nice shorthand. Write 1 line of code instead of 1, which is very useful. Next, yes, 2021. Numeric separators. This new feature allows the numeric literals to use underscores as separators. This allows us to really improve readability. So when you are working with lots of numbers, it can be quite hard to like actually see as a human being, like, hey, are there like 6 numbers, 7 numbers, like, or more correctly, digits? Is this an 8-digit number, 9-digit number? Like usually when you are writing by hand, we allow some white spaces. Like if you are writing some numbers, it will be much more useful for you to like write something like this. This is 1,000. This is how we're usually writing instead of this. And if you have like something like this, again, it will be more readable for you to write it by hand using some type of separator. It's just more easier on the human eyes. But in JavaScript, we cannot use like white space. And previously we had to write all numbers without separators. And it was a bit hard to read. So now just be aware that you can easily use underscores as separators, and it will allow the number to be read by you very, very easily, and JavaScript will still understand this number correctly, which is awesome. Best of the world, both worlds. Next, string prototype, replace all. So, before 2021, there was no way to replace all instances of substring without the use of global regexp. And now we are improving on it even more, and we have the new replace all method to change that. So before we had, for example, like const message with lots of pluses and message with space. We had to use regex. We have to like run message replace and using special regex syntax. All of this means that, hey, can you please find all the pluses, no matter where they are, and find more than that one plus if it exists, and replace them all with an empty, with the white space. And now with replace all, we can just throw this all out of the window and write it with much more humanly understandable syntax instead of regex, and we can just say, hey, can you just run replace all pluses with white spaces? Really, it looks like paint into my eyes. I hear it like music. I very much enjoy when I don't have to use regex and I can just use new native JavaScript methods, which are much more readable. Next, we have the logical assignment operator. This is the buildup of previous logical operators, like we have and, or operators in JavaScript, and they allow us to compare things. And these are the combinations of them, like we have and equals, or and equals, nullish coalescing and equals even. So this is extremely useful. We can combine logical operators and assignment expressions. So here we can see 3 examples. Let A is equal to 1. So is A truthy, like and returns truthy value, and A is truthy, let's then change its value to 3. We just wrote a one-liner and the value of A has been successfully changed to 3. Next, let A equals to 0. Then we are using our logical operator or returns false values. Okay, A is falsy. So if A is falsy, and it is, please assign to it 3. And again, with one-liner, we compared A, is it truthy? Is it falsy? It's falsy. And then we are assigning 3 to it. And then we even have our big pro nullish coalescence, which we were talking about before. And now we can even check, hey, let is undefined. Is A undefined using nullish coalescence? Yes, because nullish coalescing checks for undefined or null. And then we are assigning 7 as a value of A. So this is extremely useful as a shorthand. Instead of writing more code, you can write less. So I suppose, as you can see from year to year, JavaScript is building up on the features it's adding. Like first, we only had the truthy, falsy check. Then we added the nullish coalescing check. Then we built upon it once more, and now we have the logical assignment operator, and we can even use the new nullish coalescing logical operator together with this assignment, which is awesome. Next, promise any. As we were talking in our Ajax lecture about all things asynchronous JavaScript, we together discovered that nowadays we are not using the XML HTTP requests. Instead, we are mostly relying on promises. So, as you can see, in each and every year, JavaScript is adding some new spice, some new twist on the promises to make it even more easier and convenient to use. Because nowadays, promises are like the standard of handling asynchronous code in JavaScript. And as we remember, all of our server requests, all of our operations with the DOM, all of operations which user is inputting, user events, all of them are asynchronous code. So promise any method returns a promise that will resolve as soon as one of the promises is resolved. If all the promises are rejected, the method will throw an error. So what is this? We have previously studied the promise all method. It waited for all the promises to resolve, and only then it gave us an array of items where each item equals to the resolved promise value. And here we are waiting for any promise to resolve. We have several promises, and for example, you want to do something as soon as any of them is resolved. And now you have this amazing method. So here we have first promise, and it will reject in 1000 milliseconds. The second one will reject in 2000 milliseconds, and the third one will reject in 3000. Then we have the try catch block, and this allows us to easily catch errors. So try. We are waiting for promise any, and this method accepts an array of promises themselves. And we are waiting until any of the promises was fulfilled. All of the promises in this specific case were rejected, and we will throw an aggregated error. If any of the promises resolved, then we will return a promise. So more and more static promise methods are being released in JavaScript every year, and I suggest you keep a close eye on them because promises are our bright future as much as XML HTTP requests are our dark past. And now the new JavaScript. This is ES 2022. It is so new that it's not even released yet. It will be released this year in June, so very soon. It's already April now. So let's see which of the new amazing features we will be able to soon incorporate in our code this summer. Top level await operator. Again, JavaScript is building upon its previous features. We have introduced async and await in JS 8. And now we have the top level await operator. Previously, as I have written in my examples in the chat, you had to use functions. So you had to like write a function and it was asynchronous, and then we had to wait for this function to fulfill with await keyword. And if you try to write the code as is here on this slide, you would receive an error. It is not wrapped in a function, but starting this summer, not anymore. We can now declare the await operator outside of asynchronous functions and classes, and it really solves our synchronization issues because with JavaScript, as we have synchronous and asynchronous code, and we have to orchestrate how they work smoothly together, you will run in synchronization issues lots of time in your work. And this top level await operator allows us to safely wait for resources, require other modules, and so on and so forth. So you can safely await for something to happen and then run with your code, which is amazing. Like you can be sure after writing this syntax that inside the user, there will be no like promise pending, you will get the value. And then when you are using inside your synchronous code, then you have, for example, the synchronous function, which has your user inside it. It accepts it as a parameter. Now, with top-level await operator, you can be sure that you will await the user value, and then you can safely pass to your synchronous code again. So this allows us to really smoothly go from our synchronous code to synchronous code and to asynchronous back again, allowing us to do it much more cleanly. Then, class field declarations. As we have studied in our inheritance lecture, JavaScript inheritance is prototype-based, but nowadays, thanks to year 6, we are mostly using classes for inheritance. And classes, we initially were only able to declare the class fields inside the constructor. I suppose you remember the syntax. We have class human or something, then we have the constructor. Inside of it, we have all the properties, and outside of the constructor, we have all the methods associated with this class. And writing constructor, constructor, constructor again and again, JavaScript is giving us a lifeline to, again, reduce the boilerplate code we are writing. Like boilerplate code means that I have to write it so that things work, but it does not add like any additional value to my code. It's just there so that it works. Same as, for example, the destructuring solved our problems. Previously, we had to write the name of our parent object again, and again. Otherwise, we would get errors. But with destructuring, everything works more cleanly now. Same with class field declarations. Now, we can not call the constructor and very simply, very cleanly add new properties to our class, which is amazing. Even more awesome, the very, very much long-awaited feature of JavaScript are private methods and fields. They were a long time coming. We had them in 2020 specification, in 21 specification, but finally this summer, this thing will happen to us. What are private methods and fields, and why are they awesome? When you are writing in JavaScript, when we were studying the object-oriented programming, we were studying its principles, and one of it was encapsulation. That means that we need to have an interface for our object to communicate with outside world. And we want to protect the data on our object so that no one can just go there and change and break everything. We want to provide a clean interface to communicate with our object. But JavaScript, due to its nature, all of the fields were public. So actually you had to use like object writable, object freeze properties, and so on and so forth. So you had to do lots of extra work to protect the data on your object so that it is not replaced, it is not rewritten, because yeah, you could provide getters and setters, but nothing prevented your users, I mean other programmers which are using your code, to just directly override the methods and properties on your class, which is bad. And now, finally, JavaScript is receiving private method and fields. You just have to add this special symbol as the prefix. And when you add it, it means that if I, for example, try to run something like hello title equals something, then I will receive an error. This was previously not possible in JavaScript at all. You could change anything and everything unless you froze your object. But again, it required more code and more manual work from you. So now, because I have changed my title property and I have introduced it with this new symbol, it means that it is private. Private methods and fields, they can only be accessed on a class. And that's how I can finally encapsulate everything properly in JavaScript. So here I have title property, it is private. And if I want to get it, I have the public get method. And here inside of the class, I can reference my private field title and I can return it. So now I have provided a clean interface to the users of this object. They can only get title field using getter. And then I can set it again, not just writing the title and equal it to something. I can only provide setter, and then I will be able to set it, which is amazing. And you can also have private methods. For example, the set method can be private as well, and no one from outside your object will be able to set its title. Only the class itself will be able to. And then, last but not the least, add function for indexing. Lots and lots of times we have to index things in our arrays. So if you want to fetch a specific element in an array, previously we had to use the square brackets. Nowadays, this summer already, we will be able to index the string using both positive and negative indexes. So we can just leverage this add function, and instead of adding the square braces and passing the value of the index there, we can again simplify our syntax, use regular braces, and we can input negative index and positive index. For positive values, we will iterate from left to right, and with negative index, we will begin iteration from the end, right to left. So our lecture is coming to an end, and today we have studied lots and lots and lots of new features. I suppose this lecture could be a bit overwhelming, but the main takeaway shall be is just be aware that lots and lots of features are existent in JavaScript. Like it does not end at let, var, const, functions, and prototypal inheritance. Language is alive, it's evolving. Thankfully, JavaScript is an extremely popular language, like it's not going anywhere anytime soon. Everything web is written on JavaScript, and that's why it's developing so quickly. Each and every year nowadays, we are consistently receiving new amazing features. What's even more awesome is that these features, they are not being added just because. They are being created by users. And in the future, if you want to do something, you can actually go to ECMAScript website and you can submit a new feature for review. You can say like, hey, so and so, I think that this feature will be extremely useful in the future JavaScript. Like lots and lots of people have to use this very verbose syntax, and I suppose this new feature will fix our problems. And that's how these features are being added. Maybe you've noticed when we were talking about 2022, we said that lots of features have reached stage 4. Stage 4 means stage 4 of talking about them, voting for them, refining them, writing specification for them. So it's all very democratic. Everyone can submit a new feature, but then it has to go through a very rigorous refinement and voting process to actually end up in the JavaScript. Sometimes feature can be just very hard to implement. This is what happened with private methods and fields. This feature was very, very much anticipated and much needed. For example, TypeScript, the superset of JavaScript. TypeScript has access to private methods and fields for some years now. And it's actually one of its selling point compared to JavaScript. Like, hey, TypeScript has not dynamic but strict types, and it has private methods and fields. So it's really awesome for an object-oriented programming. Everyone go TypeScript. But now JavaScript is gaining high ground once again. We will finally this summer have access to these private methods and fields. So sometimes feature can take a long time to implement just from a technical perspective, from technical point of view, and we will have to wait. But the most amazing thing of all is that each and every one of us can submit new features, or we can take part in negotiations. We can vote for features we would like to be added, and we can just, like what it's called, to keep our hand on the pulse of the language. And I suppose this is the key value of this lecture, that JavaScript will be always evolving. Each and every year, each and every month of your future career, JavaScript will be not the same as it was before. If you let go of this, if you don't keep up with the times, you don't study new features, it can quickly become overwhelming. So it will be much better and much easier for you yourselves to just be in the loop, to study JavaScript year by year, to try out new features. This will help you as a developers, because what we have studied today, I am hoping I was able to show you that these features allow us to write our code more cleaner, make it more understandable, reduce the boilerplate, help us with the issues we previously faced. And with that, I am happy to finish my lecture and ask you, do you have any questions regarding the new features of JavaScript? You are still on the asynchronous JavaScript. If you have any specific questions, asynchronous JavaScript, it can be quite tricky. I suppose there are two amazing things that you can watch. One of them is called In the Loop. I have linked it previously, but I will link it once again. And then there is a second very nice thing, which is called very verbosely, what the heck is event loop anyway? And I will link it as well. They are both from the JavaScript conference. One moment. So yeah, here's this video as well. Let me link it in the chat. Here's the second one. So after watching these, I am really hoping that you will get a better understanding of how asynchronous JavaScript work. And remember that nowadays we have access to lots and lots of articles and courses. Like, for example, I really like Udemy for all my JavaScript and React needs. So you can take some courses on asynchronous JavaScript, and also let me look it up really quickly. I suppose on Free Code Camp, we also have some good courses. Yeah, so here's a quite fresh tutorial. Free Code Camp is amazing that it's like, well, free, as it says from the name. So here is a really good practical tutorial for working more with async, waits, and callbacks. Asynchronous JavaScript can indeed be very intimidating in the beginning, but when you get a better grasp at it, make first few steps, it will become easier and easier down the line. So I'm hoping that these videos and this practical workshop will be able to help you. Do we have any more questions? Okay, if there are no more questions, then I'm happy to say that this is the end of our lecture. I'm hoping that you learned something useful today, and these new features will be used by you in your future work. For now, I will take a step back for the next 2 lectures, but then I will return to you as a teacher at the very end of our course. And with that, I'm wishing you an amazing Wednesday, and as always, it was a pleasure to teach you. Have a great evening.
Bye, have a great night.